Okay, let's talk about the quadratic formula. The quadratic formula is another way, an alternate way of finding the solutions, the answers, the roots to a quadratic equation or a second degree polynomial equation in standard form. And a second degree polynomial equation in standard form, the roots, remember, we can find by using the zero factor property. And the quadratic formula is not meant to be used as an substitution for using factoring. Factoring is the better way to go about it when and if it's possible. But not all quadratic equations, polynomial equations of second degree, will be able to be solved by factoring. So the quadratic formula gives us an alternative when we can't factor. Now I'm going to show you some examples that can be factored using the quadratic formula just because they're very simple and basic. And without knowing a lot more about radicals than we do already, we don't want to get too deeply involved in the quadratic formula. So first of all, standard form, ax squared plus bx plus c. The a and the b and the c from standard form, remember standard form, these things are going to be what's in this quadratic formula. So the quadratic formula says we take the b and take its opposite, so minus b, and then do plus and minus. We're going to do both of these. That's what that means. The square root of, and we're going to take the value of b and we're going to square it, and then we're going to multiply times 4 times a times c, and then all of this, the whole thing, is going to go over 2 times a. And that is the quadratic formula. So now let's go use the quadratic formula. So here we go. Here's an example. Now this is absolutely a factorable example. So I'm going to write down a equals 1, b equals, and it goes with its sign, it's a negative 6, and c equals, and again it goes with its sign, it's a negative 16. So we have those as our formula. So the roots of this, the solutions to this quadratic equation, are x is equal to minus b, so the opposite of whatever b is, so the opposite of a negative 6, plus or minus the square root of whatever b is going to get squared. So minus 6 goes in there getting squared. Minus 4 times whatever a is 1, times whatever c is a negative 16, and then all over 2 times whatever a is. And so now we're going to simplify the numerator. So this says positive 6 plus or minus, and negative 6 squared, negative 6 times negative 6 is what that says, remember. And a negative 6 times a negative 6 is a 36. And then negative times a negative is a positive. So this is going to be plus 64. Because 4 times 16 is 64, and so this is going to be the square root of 64 plus 36, which is 100, and then that's all over 2. And so now we're going to simplify this into 2 parts. So what this means is that 6 plus the square root of 100, which is 10, over 2 is one answer, or x could also be equal to 6 minus the square root of 100, which is 10, over 2. And so that means we have either 16 over 2, which is equal to 8, or we have 6 minus 10, which is a negative 4, over 2, which is equal to a negative 2. Now, if you'll remember right, if we factored this, right, the factors of 16 that give us a difference of 6 would be an 8 and a 2, with a negative 8 and a positive 2. And what you're seeing here is the opposites of these answers, right? The sign in these binomials are the opposite of what the answers are. But when you set these equal to 0, zero factor property, right, and solve, you're going to see that x is equal to 8 here. And set this factor equal to 0 and solve, and you're going to see what the answer is right there. And that's how the two relate. Now again, this one you really should be factoring, right? This is factorable, therefore you would want to factor it. But this is how the quadratic formula is used, and I want you to see that. Now we're going to do B and C in the next video.